Okay? So we're entering one of the final chapters on linear regression. So we're going to talk about regression basically until the end of the semester. But I'd like to talk with probably the most important or definitely the most prominent part of regression, which is linear regression. So just by a show of hand, who already knows what linear regression is or have seen some of it, like fitting a straight line through points? At least, okay, so you have an idea of what the plots are going to look like. And we're going to try to understand a little deeper, right? Again, that's the idea of this class is that we just don't draw lines that go through points. We just try to understand what's actually going on. And so the goals here of regression in general, and more specifically of linear regression, so this is actually a blanket goal for all of regression, is given two random variables, x and y, you typically want to essentially predict y from x, okay? So if you're in this class, probably some of you want to know how to predict things, and that's what machine learning is doing. You're just given something, and you're trying to predict something that's harder to figure out. So here are two examples. So this is going to be the data set I'm going to be playing around with. So there's a data set on Kaggle about Facebook ads, and so it's a lot of data. And x, so you can pick whatever x and y you want. So here I picked two pairs x and y. The first one is x is the amount of dollars spent on Facebook ads, and y is the total conversion rate, right? So predicting y from x is probably a pretty good idea if you're going to invest in some Facebook campaign. And y, so conversion rate is people who click and then end up buying on your website. And for example, another thing you might want to ask, or for example, just to have a little bit of variety in terms of what kind of random variables we're looking at, to have a discrete random variable, I'm going to take x to be the age of the person. So somehow Facebook has pretty accurate predictions of what the age of the person interacting with the ad is. So it's within some age range, for example, I don't know, 30, 40 to 45, something like this, you'll see. And y is, for example, the number of clicks, right? For example, you might want to see if you might want to target different ages differently because they actually lead to different numbers of clicks, okay? So you can ask any question you want in general. Of course, I'm sure I can ask each and every one of you. You have a particular x and a particular y that make more sense in your mind. This is the data set we're going to be working with. Now, given these two random variables, here are the bunch of questions we can ask, okay? As I said, probably the most natural one that you might want to ask is, can I predict y from x, okay? So you're just given x. Y is harder to know, either because it's something that's going to happen in the future, which is the examples that you have here, or it's just something that's just hard, right? So one of the examples that exist as a smaller data set is, for example, people want to measure some sort of body mass index that's more accurate than just the ratio of two numbers, right? I find it actually kind of funny when I go to the doctor and it's like, this is your height, this is your weight, and I'm going to tell you exactly how healthy you are based on those two numbers. And so what people are doing, typically the way you want to measure this is this body density that can immerse you in some water and measure how much density you have in your body, and that measures the amount of fat that you have in your body. And of course, this is not something you want to do every time you go to the doctor, and people try to find some proxies to do this. And for example, there's several measurements they can take on your body and hoping that some will actually be good predictors. So for example, it turns out that some transformation of the circumference of your wrist and maybe some, on your weight and things like this actually are pretty good indicators of what's going on. So you want to predict something that's hard or impossible to know at the given time, from something that's easy or cheap to actually get. You might want to get some error bars, right? If I tell you I'm going to invest $100 on Facebook ads, you might want to actually give some error bars about how much conversion rate this will give me. You might want to understand what is the derivative in a way, right? Like if I invest an extra dollar, how much more this will give me, right? Is this diminishing return? Is this increasing returns? Is this linear returns? I want to know if there's some particular things I need to do, right? Maybe the amount of dollar is not the place where I actually want to invest too much more. Maybe there's some things that will give me much more mileage by investing there. Some questions that are even about testing kind of questions. Yes, no. Does the number of clicks even depend on age, right? I mean, is it even, reasonable to think that, people of different age groups are going to have different clicking behavior? So that will be important, for example, if you want to understand, well, for example, actually you could ask this question, is the number of conversion, even depending on how much dollars you put in Facebook. So a no answer to this question would actually be pretty dramatic. I'm pretty sure if that was the case, Facebook would not have released this data set. And then what if X is a random vector? All right, then actually most of regression we're going to talk about, it's not just about a variable. You have a bunch of measurements, right? When I describe this example of measuring, say, the amount of fat in the body, you have maybe 5 or 10 measurements you can actually work with, not just one. Okay, so here, for example, the data set that we have for Facebook, there's probably 20 variables that are measured for a particular transaction. And so you might want to combine them to actually get a better and more accurate prediction of the conversion rate, for example, right? Maybe you want to combine age and amount of dollars spent and duration of the campaign. You can do a bunch of different things to combine and try to have a better prediction. All right, and that's what machine learning is all about. Okay, when you do modern machine learning, you collect as many observations as you can, and you try to put them together to predict something that's going to happen. Okay, so this is one scatter plot of this data set. All right, so you can see there's actually quite a bit of points, and this is the amount. The x-axis is the amount spent on a campaign, and the y-axis is the total number of conversion. All right, so clearly there's an upward trend. The more you spend, the more conversions you're actually getting. There's lots of people that are right here, don't spend that much, don't get that much conversions, and what we're trying to do is to say, okay, if I'm here and I want to spend $500, can you give me an estimate of how much I'm going to be making? Okay, so here clearly there's no particular point that will actually give me here. So let's say here I want to spend $500 on this campaign, and I want to know where this point actually ends up being on this line. Okay, and maybe I'm going to have something accurate, maybe I'm not. Is that clear what we're trying to do here, for example? And maybe I want an error bar around this. So when I do a discrete x variable, this is what the data looks like, right? So here there's only 4 age groups, 30 to 34, 35 to 39, et cetera. And here you can see how much clicks each of these people actually gives you, right? So a dot is a person corresponding to a particular age group and how many clicks you can see.